everyone. So today's ed puzzle is going to be about even and odd functions. So previously we've talked about even and odd degree polynomials. They're a little bit related, but they genuinely mean two different things. So the rules are going to be a little bit different here. Basically, for an even function, the function is unchanged when reflected about the y-axis. So what this means is that when you plug in negative x to the function, you get the exact same function back. So here, if I go and put negative x into this function, negative x squared, that's like negative 1 squared, which is positive 1, and x squared. So that's like 1x squared, right, which is just x squared. We get the exact same function out, okay? So that means that that function is even, all right? Now, another thing that even functions have is that they can be reflected across the y-axis. So imagine if I were to fold this on the y-axis there, this would directly lay on top of this, okay? So that is another feature if you're actually looking at the graph. All right. Then we've got odd functions. So with odd functions, when you plug in negative x, it essentially negates the entire function. Everything in the function becomes negative. So here, if I put in a negative x cubed, well, negative 1 cubed is negative 1, right? And x cubed is x cubed, so our answer would be negative x cubed, which, as you can see, if I were to just multiply everything here by negative 1, I would also get negative x cubed. So you can see that this is an odd function. Another feature of odd functions is that the function itself can rotate 180 degrees about the origin. And what that means is that if I rotate this 180 degrees, everything ends up in the same place. I know that wasn't perfect. That was due to my poor drawing and rotating. But you could see that, right, when we rotate it, it has that symmetry about 180 degree rotation about the origin. All right, and here's just visually some examples of odd functions. All right, you can see here, this doesn't have symmetry across the y-axis. However, I'll try and do my best here. Maybe we can see the symmetry. I know it's not going to be perfect, but we'll try. If I were to rotate this about the origin, right, we get that 180 degree rotation about the origin, okay? So that is a feature of an odd function. Even function, right, if I were to fold this on the y-axis, these would perfectly go on top of each other. So that shows the symmetry there. Now here, these show functions that are neither even or odd. Right, if we look here, it's definitely not even, because there's no symmetry about the y-axis, and then it's not odd, and you can see just by looking at it, right, if I were to rotate this 180 degrees about this, about the origin, we're not getting the same function. It's going to be upside down. So yeah, same thing here, right, we don't have that symmetry across the y-axis, and if we were to rotate this, we don't have that symmetry about the origin. So kind of looking at the functions, you can... when you have the graphs in front of you, you're able to tell if they're even or odd. All right, so let's go ahead and try this one here. So if we take a look at this polynomial, we're going to go figure out what f of negative x is equal to, okay? And when we do that, we get we get 1 minus negative x raised to the power of 6. Nothing changes with the 1. Negative 1 to the 6th power is going to just give us a positive 1, and then we end up with x to the 6th. So we get 1 minus, and then 1 times x to the 6th, which is 1 minus x to the 6th. We got exactly what we started with here. Okay, if we get exactly back what we started with, this is an even function. And I can, of course, go to Desmos, and let's see, 1 minus x to the power of 6. You can see that this function does have that symmetry across the y-axis, if we were to actually graph it. All right, now let's go ahead and try this next one. So if we go and do f of negative x, we end up with negative x to the fifth minus negative x, I should say minus negative x. There we go. All right. So then, right, this is like a negative 1 out in front. So we end up with negative 1 to the fifth, x to the fifth, and then minus a minus is plus. All right. Negative 1 to the fifth power is negative 1. So we end up with negative 1 x to the fifth plus x. We get negative x to the fifth plus x. Okay. So now, obviously, we did not get what we started with. So now we have to see if it's odd. All right. If this is odd, if we were to multiply this entire function by negative 1, we should get the exact same thing. So I'm going to go ahead and slap a negative 1 out in front here. We've got x to the fifth minus x. We distribute the negative. We get minus x to the fifth plus x. That is, in fact, what we got, okay? So, and if we look back up here, that's what that means, right? If you put negative x in there, you essentially negate the entire function. That's what's happening here. These are equivalent, so this is going to be an odd function. All right. So now let's go ahead and do this next one. So we're going to go and do f of negative x. We're going to do 7 times negative x to the third minus 4 minus 7 negative x squared. Okay. So we get 7 times, and then, right, we have a negative 1 to the third here, x to the third, minus 4, and then minus 7 times, and then we get negative 1 squared, x squared. So this negative 1 to the third power is negative 1, right? So we're going to end up with 7 times negative 1, get negative 7x cubed. We get minus 4. Now this one is negative 1 squared. That goes to a positive 1, so we end up with minus 7x squared there. All right. So now we have to look. Did we get the exact same function that we started out with? No, we did not. Okay. So now we have to see, okay, did we get essentially a negated function? Okay. Did we multiply everything by negative 1? Well, if I were to do that, I get 7x cubed, minus 4 minus 7x squared. I distribute that negative. I get minus 7x cubed plus 4 plus 7x squared, which that's not what I got either, right? This guy changed to what I wanted him to, but these did not, okay? So this one is neither. All right. All right, and then we have to go ahead and check here. So now what we're doing is they're giving us polynomials, and we have to determine if the degree is even or odd, and then determine if the function is even, odd, or neither. Okay, so if we look here, all right, the end behavior is going in opposite directions. And if we think back to the beginning of this, right, even functions, the end behavior goes in the same direction, whether that's both up or both down. That obviously depends on the coefficient. But for even functions, they go in the same direction. Odd functions, they go in opposite. Odd degrees. I misspoke. For odd degrees, they go in opposite directions. So if we look here, right, we are going in opposite directions. So this is going to be an odd degree polynomial. All right, now we have to determine if it's an odd function. Now, it kind of looks like it could be an odd function, right? But essentially, to be an odd function, you have to go through the origin, okay? Because you need that rotation. And I'll show you why this doesn't have that rotation. If I were to rotate this, do you see how we don't have that symmetry? Okay, if you're an odd function, you have to go through the origin to have that rotational symmetry. If you notice, right, this odd function goes through the origin, this odd function goes through the origin. So you have to go through the origin to have that symmetry. And we can see that it doesn't have that rotation. So this one is going to be an odd degree, but not an odd function. All right, next one. So this one, the end behavior, both going up. So this one's going to be an even degree. Now, to determine if it's going to be an even function, we have to look, okay, does it have symmetry about the y-axis? In this case, it does, right? If I were to fold this across that dotted line I just drew, the function's going to, overlap itself. So this is going to be an even degree and an even function. All right, next one. This one, our end behavior is in opposite directions. That's going to be an odd degree. right? Specifically, it would be an odd degree negative leading coefficient, right? But we've got an odd degree, and now we have to determine if it has that symmetry, okay? So if you look, right, you can see, okay, we have 1, and then we go positive there, 1, negative there. You can pick another point too, like, I don't know what would be a good one to look at. Like negative 4, 50. When we go to 4, we go to negative 50, okay? So we can see that it has that symmetry there, right? There, for a positive one, we go to negative 50. I'm sorry, I'll write out the points so you can actually see. So for a positive 4, we go to negative 50. For a negative 4, we go to positive 50. So you can see that there's that symmetry there about the origin. And I can even double check, right, by trying to do my little turny thing here. All right, we rotate. And again, I'm not perfect with it, but you can see that it does have that rotation. All right, that rotational symmetry. So this one is actually an odd degree and an odd polynomial. Or, I'm sorry, an odd degree and an odd function. So it's odd degree and it's an odd function. So that's going to be our answer there.